the outset of that session. So I would love Carl Bass to join me right now. Carl Bass, who's the CEO of Autodesk. You know, manufacturing used to be the domain of big companies, but it really isn't quite that simple anymore. And I love CEOs of big companies who come to stage with a T-shirt like that. And
I got dressed up to come here too.
You did, really?
I did.
What do you wear? Your underwear at the office?
You should see me in my shop.
Really? Oh, yeah. Well, you're a shop guy. We'll get to that in a second, actually. Yeah. I like that. But so we're talking about the shape of manufacturing and how it's changing. Technologies like 3D printing, satellite, everything from satellite components to shoes are being made with 3D printing. But when you look at the big picture, and you're a software company that basically builds design software in its essence, right? That's the main thing you do at Autodesk. So when you look from that vantage at what's happening with making things and manufacturing, what's the summary point you would make to sort of start this big picture conversation?
The biggest thing that's changed is not only have computers changed how you design and engineer stuff, but they've totally changed how we're making stuff. So the bigger point about 3D printer isn't the 3D printer. We can talk as much as you want about 3D printing, but you finally have taken the power of a microprocessor and now applied it to a manufacturing process. And if you look across the spectrum of really interesting things, that are here and on the near horizon, it is all about being driven by microprocessors. If you look about manufacturing the future, it's just like your previous guest said, I think the future is biological.
Well, I want to get to that in a minute. That's very good.
I knew that was a tease.
No, I like that. But be a little bit more specific about where processing will affect manufacturing in the future beyond 3D printing. What's a way that it might do that we're not thinking about?
I mean, the way to think about it is, if you think about the Industrial Revolution, what came about as a result of the Industrial Revolution, we were able to make really high quality things at reasonable prices if we made a gazillion. It turns out with the advent of computing in there, we can now do that exact same thing, but you don't need to make a gazillion. You can do this on one or two, and so you can make custom and bespoke stuff in ways that were never possible. We don't need to make 1 million plastic widgets in order to get that economy of scale. The 3D printer is happy making one is 1,000.
So does that mean economies of scale go away and we don't have some products that benefit from that? Is everything moving to this model?
No, absolutely not. It will still be, the best thing to do will be to make plastic widgets that cost 2 cents. Probably plastic injection molding in low cost labor markets will still be the way of certain products, but it's opening up a whole new area of products that were never possible before. Okay. You couldn't do custom products at an affordable scale.
To ask a contrary question to the one I just asked, which sort of presumes that 3D printing is here, I mean, I was at a session at the Aspen Ideas Festival this summer where people in the audience were asking, what is this thing called 3D printing? So it isn't so established yet, right? You talk about it like it's kind of a given, but how soon will it really be a given where we're seeing mass influence of 3D printing across our lives? Because it hasn't happened yet.
Okay, so I'm a bad predictor. My first 3D printer I saw 25 years ago. So I'm a little jaded by this.
It's been around for a while. But it was super expensive.
Yeah, and it didn't work really well. It still doesn't work really well. So I've seen it since the 80s. That's when it was really invented. On the other hand, I was just doing an interview and one of the tech guys, he said, oh, 3D printing, let me show you these new headphones. So these were custom headphones. He had his ear, he took a picture of his ear with an iPhone, and 2 days later he said he got these ones delivered and they fit perfectly.
Right.
So it is starting to go mainstream in some ways. It's not totally mainstream, but it's definitely getting there. And there are a couple things to think about 3D printing that are interesting. One is, on the good side and why it's going to continue to evolve. The shape of something you're going to print, the complexity of form doesn't matter. The 3D printer will print the most complex thing, and you don't need any particular craftsmanship to do it. So you don't need a lot of capital-intensive equipment, and you don't need huge manual skills. You can make a 3D model on a computer and you can produce it, and I can send that file around the world or to outer space or to the bottom of the ocean, and we can make the exact same part anywhere. And that has huge possibilities.
Okay, but I want to get a little more into how you're thinking as the CEO of Autodesk, which is a multi-billion-dollar company that builds software for designing buildings and cars and all kinds of things. You know, how far, I mean, how much of what you're doing is going to continue to be implemented in traditional manufacturing, and how much of the use of your software is going to result in outputs in 3D printing or other radically new types of fabrication?
You know, I think the history of us humans as tool makers is that we will continue to evolve and add to it. So I don't think some of the things that we do now will go away, but if you look at the future, there is no doubt that, you know, additive manufacturing, the general category of 3D printing, subtractive, these very high precision machine tools, robotic assembly and manufacturing, and then bio and nano will be the tools of the future. You know, at a certain point, it will still be driven by the same underlying factors that have always driven. What's the cost? What's the reliability? You know, how much upfront versus how much on a run rate basis? So you'll have the same things, but we're really just adding to our toolkit this whole range of possibilities that were never even imaginable before.
Okay, well, since you've mentioned bio twice, I cannot go there now. So why is Autodesk getting into bio? I know you have a whole new division. You've hired some smart people, some of whom have spoken at Techonomy events.
Yeah.
Tell us about that.
So I think one of the limitations of 3D printing, and we'll approach it from that thing. One of the limitations of 3D printing is that things go up as the cube power. So it goes up as a power of 3. So if I want something that's twice as big, it takes 8 times as long. If I want something 3 times as big, it takes 64 times as long. So fundamentally, you will always be fighting that. And just like in computing, there will be breakthroughs and there will be things we can do in parallel. But fundamentally, you always will be fighting the power of 3. Biological processes are one of those things that get around that. And we are harnessing the tools to actually be able to grow things differently. I mean, if you think about it, so you just
Not just food, though. Yeah.
Not just food. Well, because we can 3D print DNA and manipulate DNA, and people are 3D printing DNA, you can mail order DNA. You think about it and you go, the Ebola virus that everybody is talking about, you just mentioned Larry in that context, it's 2,000 bits of information. You think of a tree, you know, something like an oak tree, and it's a megabit of information. Relatively small amounts of information that we need to manipulate to get outcomes that we know of.
So what are you doing with this right now at Autodesk?
So what we're doing is we're saying, just like we're doing with 3D printing, our customers are interested in making things, cars and planes and the infrastructure of the future. And what we're looking at is saying, what lessons can we bring from what we learned in helping people design in the inert world and bring that to the biological world? So for example, we're working with a group at Harvard that's doing nanoscale robots for drug delivery.
And you're providing the software that
Right.
allows them to do that
Yeah,
now.
you still need to design this thing. So, okay,
Yeah.
I have an idea, I have a robot, and whether the robot is, you know, a robot like this or a nanoscale robot, somebody has to design that mechanism. And we're giving them the software tools that help them design that.
One of the things, I want to just switch to another thing.
Yeah.
You yourself are a maker and a craftsman, and I think it's interesting that you are as the CEO of Autodesk, and I'd love to just quickly take a divergence to show some slides that you brought that show some stuff you've made, right?
Okay, sure.
Could you just quickly walk us through those? Can we get those slides up? Can you see the?
Oh, yeah.
Yeah.
Yeah,
Oh,
so
yeah,
one
there
of
we
the, oh, yeah.
We don't have to spend too much time, but
Yeah,
I think you just should quickly
You,
show.
you quickly flip through. So I built a lot of boats, both, you know, traditional.
You built all of this stuff
Yeah.
we're seeing. You're
Yeah, yeah, yeah.
entirely yourself?
Yeah. Well, that other boat I worked with a friend on. This I worked with a friend on. It's either me or, you know, 1 or 2 others.
What is that?
That's a bench that I carved out of black granite.
You carved that out of black granite? Wow. What kind of, so you have some
That's what I
kind
told you. I got way dressed up for this.
Yeah, wow.
you should see what you look like after
That's
carving black
is that
granite.
a table or stool?
Yeah, it's actually it's a table, and it's made out of concrete and mahogany.
Wow.
And so yeah, no, I spend a fair amount of time.
Okay, what's this?
This is a table. It doesn't have the top on it. It's a table that I've just carved using. This is one of the first ones I've done with CNC machinery. So this is
CNC, computer controlled.
Computer controlled machinery.
Which, of course, was controlled by software from Autodesk.
Right, exactly.
Yeah, and that's beautiful.
Thank you. This is there's a whole series of these. I tend to make them, and they're a little bit like rabbits. You know, they end up all over the place. I have dozens of these things. This first one I made by making a wood version of it, and then I cast it in bronze.
That's a vase, or?
Yeah. So it's like this big, but you could kill someone. It probably weighs like 10 pounds. Oh, this is a series of 3D printed speakers I made. But
you really run the gamut. That's quite a range. Where do you have time to do that?
Well, I was going to say, I don't, so a lot of these things are relatively small. The boats I built, some of that work goes back 30 years. I don't have that much time, so I tend to do design experiments now. I think of them as relatively small because I do have a full-time job.
Quickly, yeah, how does that alter the way you think?
Oh, this one is totally cool. This is my son and I. We built a electric go-kart last year. So this is got a 20 horsepower electric motor. It goes like 55 miles an hour. And
How old is your son?
it's about 2 inches off the ground. We started it when he was 15. We finished when he was 16.
Okay. If there's any more, let's quickly go through them.
Yeah, I think that.
Oh, there you are as a young craftsman.
Yes, exactly.
Okay.
Nice.
Nice.
Yeah. So some traditional thing that's from way, way back.
I have to say, among other reasons why I like this, at Techonomy, we're always trying to celebrate the intersection of the arts and business and technology, and this is one way of doing that. But how, and to continue on that theme,
Yeah.
how does the fact that you do that affect the way you think about being CEO of Autodesk?
I mean, I hope in some ways. I mean, I think many people could do this. Everyone who was the CEO before me didn't do this, and I'm sure the people after me won't. But what I hope it does is gives me a greater appreciation and empathy for what all of our customers are doing.
Right.
The most fortunate part of my job is I get to work with the most incredible and creative people. Whether it's the people making films like Avatar and Lord of the Rings, or people who are designing buildings around the world, or all the car designers. And so in just a small way, I hope it gives me an appreciation of what they try to do for their job.
Well, that sounds important.
For me it's fun, but for them, this is what they do every day.
We're going to bring up a couple of other experts in this field of how making things and manufacturing is changing. But before we do that, I wanted to ask you about, you've talked about robots. There's an awful lot of automation happening in your world in the making of things. And it's already come up in our discussions here and in other events we've done repeatedly. What's happening with jobs? Is there a future for the middle class? What's your thought on that?
I'm not overly optimistic. So I think you should be certain that lots of what are traditionally middle class jobs are going away. Various forms of automation are eliminating those jobs. You start with factories, and they've been hollowed out of people. You think about driverless cars in the context of most of the people in this room will end up having driverless cars, but that is tens of thousands of jobs that provide livings for people that will not be there in the future. And so in my mind, there is no doubt the people with the skills who can design and build those things, there's a future for them. I think there's a much more serious conversation that needs to happen about what happens in society. What happens when the robots take our jobs? What are we all going to do?
Okay, but what about the possibility that more people could do stuff like what you showed us in your
I think
slides?
that'd be great. One of my ideas that's only half facetious is that we should tax robots instead of people. Seriously, that if you think about it, if I as a factory owner want to put in more robots, you should be taxing the capacity, the output that I produce rather than the individual people. Because what you actually have to do in some way is figure out how do we pay for the infrastructure and everything else that supports this. And so I don't think the individual problems there. As a matter of fact, I think it's Keynes who in the 30s wrote this paper, and he was lamenting what was going to happen to his grandchildren because the availability of capital and the efficiency at which we were going to be able to do stuff, there would be no jobs for his kids. And that's not turned out to be true. So on one hand, I would say, look, as long as we can keep inventing jobs in front of the jobs we're eliminating, he didn't imagine in 1939 there would be a job of a web programmer, or a data scientist. So if we can keep inventing jobs ahead of those, that's great. But we need to have an education system that supports those kind of jobs Right now, I think, you know, we're teaching kids in schools for jobs that don't exist, for a future that doesn't exist. You know, the idea that the schools were taking people from agrarian, you know, to factory is a future that doesn't exist for them, and things like the education system need to change.
Okay, let's bring Liam and Marlene up on stage to join us. Two more people who are real expert at this concept of how manufacturing and making things is changing to just continue the conversation. Marlene is a co-founder of Shapeways, which is a company that is a remote fulfiller of 3D printing design. So maybe you can describe it more accurately in just a second. Liam Casey is the founder and CEO of PCH, which is kind of an astonishing company that's an enabler of the creation and manufacturing of the work of other companies, and is quite innovative in the way it's operating right now at substantial scale. But Marlene, quickly talk about what it is that Shapeways makes possible, and any thoughts you've had on what we've said so far.
Well, Shapeways is a company, it's basically a 3D printing service for consumers, and it's also a marketplace. So designers can go to Shapeways and earn money by, and support their own living by putting their product designs online with Shapeways and selling them. And then Shapeways takes care of manufacturing, distribution, customer service, supply chain, all of that. And yeah, so that's what Shapeways does.
Did we leave anything out in what we were discussing about 3D printing that you would want us to urgently not lose?
Well, I was very much in sync and agreeing with what Carl had to say about it. You know, complexity doesn't matter. 3D machines are great, but they're not fantastic yet. What's great about 3D printing, the magic of 3D printing for me, is in what you can do with it and the things that you can make with it. It's not in the technology itself, because actually a 3D printer is not that complicated and nor that reliable yet. So that technology still has to evolve a lot faster, if you would ask me.
So Liam, talk about what PCH does and any observations based on what you've heard on this session, or frankly anything else today.
Great.
Or yesterday.
Great. Delighted to be here. So PCH, we're a product innovation company. We take ideas from concept all the way through to a consumer. So somebody will come to us with an idea for a product. We'll take it all the way through the development stage, all the way through the manufacturing, the packaging, and the logistics. We ship it direct to consumers' homes. And we think about our last mile is often 8,000 miles, so the logistics part is important, but also the whole engineering and development at the start of the process. One of the things where we see 3D printing being really important is that back around 2007, we worked on a project called Chumby. I'm not sure, anyone here remember Chumby? Some people, yeah. So we built the Chumby, and I remember, for me, that was an amazing opportunity, because we'd worked with all the big tech companies up to that. And then Bunny Huang and Steve came in and they started talking about this leather beanbag with a screen on it. It had touch screen, it had Wi-Fi, it had Bluetooth, and we actually built it for them. But that was where we saw a change, where we saw more entrepreneurs coming to us and engineers coming to us with ideas for products. And what was happening was they had access to 3D printing, they had access to Arduino and Linux. So these were the new fabrics of technology that we saw emerging that really got us interested in how do we work with more of these engineers, because with these new tools, we saw a renaissance in prototyping. And the renaissance in prototyping is driving a renaissance in hardware. And it's really fostering a whole amount of innovation like we hadn't seen before. And then like 2008, when engineers were being let go from companies, they were actually going into their garages and starting to work with these tools. And
software engineers that were moving into hardware.
Absolutely, and they were trying to do it themselves. And then they were coming to us with great ideas. We set up PCH Access, which is an accelerator to help them scale. We actually then set up a formal program called Highway 1, where we take in applicants. And again, in there we have a lab where they have access to all these tools, including 3D printing, and it helps them come up with samples. And in hardware, the moment of truth, one of the most important moments is where you actually give the creator that first prototype, that first sample, and just try and take it off them. And it doesn't work. They just really want to hold on to it. And that's where the creativity happens. That's where that moment of magic is. That's so important in building hardware.
But what you do is a big sort of big picture example of this world of empowerment that we're living through, where you actually have an incubator where you help people who just really have an idea, you help them create the actual prototype, then you help them find a place to manufacture it, help them manufacture it, help them deliver it. I mean, you really essentially help people create the entire product process, even the whole company process inside your company, which is quite a striking set of capabilities inside a company. Just talk about how you see the landscape shifting in terms of how quickly we will see new ideas come to fruition as a result of the existence of that kind of system.
What we see at the moment is we're seeing new companies every day and new ideas every day where people come to us with great ideas, and it's a question of how do we filter them, how do we pick the right ones. And at the end of the day, for us, we move 10 million parts a day right across our network. So for us, we know we can make this stuff. We make a lot of products. The hard thing is still the distribution and the selling. You can make all these products, but if you can't get real partnerships in the distribution and in the selling, you're going to have problems. And that's the big part that needs to be disrupted. It's interesting, if I sit with an entrepreneur in Silicon Valley, it's quite likely they'll want to make an accessory. If I sit with an entrepreneur in China, it's very likely they'll want to make a device. And when I say that, when I tell people back here in Silicon Valley about this, they'll tell me, well, we need to bring back manufacturing. And I tell them really fast, it's got nothing to do with manufacturing. It's got everything to do with distribution. It's got everything to do with the contracts that the big box retailers put in front of the startups. When you look at these contracts, we just saw one recently where it had 3 months of inventory in a channel, and it had consigned inventory in the stores and in the distribution centers. And then it had 90-day payment terms. There is no way that you will convince anyone in Sand Hill Road to fund a contract like that. And that's what we're trying to change. We did it with Radio Shack recently, where we went to Radio Shack and we said, if you want us to provide great products and great entrepreneurs, to give them a platform, what we will do is we will ship the product directly from our production lines in China. We'll ship direct to the stores. We'll ship once a week. And they agreed to it, and we actually re-engineered their supply chain where they had 3 months of channel inventory. We have taken that down to 6 days. Now, you wipe out a huge amount of risk when you do that. The next thing we said was that for these startups, we want you to give them 14-day payment terms instead of 90. And they agreed to it. We then said, okay, no consigned inventory, no right to return. And Joe and the team were actually very good. And now we actually have great startups. We've Little Bits from New York is shipping products into the Radio Shack stores on every week. We ship to some stores, we ship into 4,200 stores. In some stores, we're going once a week, and other stores, we're going twice a week. That's what's going to really create a fantastic ecosystem of hardware startups in Silicon Valley. Because when you look at other parts of the world where they don't have these contracts, the contracts we've seen here are hugely onerous and make it very challenging for a startup. What we want to do is we want to try and convince the VCs in Silicon Valley and give them a safe way to invest in some of these startups.
Okay, so here we have the software to design things more efficiently and more quickly and in a more interesting way. Your manufacturing system that effectively, cuts through a lot of the obstacles that especially smaller entities and individuals have faced in the past. And Marlene, you really actually created, you were also fabricating things, helping people manufacture things. And I know you're very interested in the environmental impact and implications of this new world that's coming into being. Could you talk a little bit about that?
Well, if you look at it from a grander scale, you see the Industrial Revolution, what Carl just talked about. Everything, to be able to make one thing, you had to make 100,000 of them. But if you look at the ecological impact of us, moving everything towards China, where, for instance, in the capital of genes, 1 in 8 children are born with a tumor, whether benign or non-benign. I mean, that's a huge impact. 1 in 8 children being born with a tumor just because the water is so polluted because of the dying of genes.
In an area where they make genes in China.
In an area where what's like the capital of the world of genes. Mm-hmm. So by shifting all of that production of the whole world in the direction of China, we've created a system where the ecological impact is not visible to us over here, but is not great for the people over there. We've created a system with a very complex supply chain that can take very long if you don't use Liam. And we've created a system where you cannot have something that is special, bespoke to you or customized. And what you now see is that with the rise of 3D printing, but actually also with other technologies, basically machines and technologies are getting smarter. And we can use those machines and those new technologies like 3D printing to make things, so to cut out that long supply chain and cut out the negative cost and impact on the environment, but also create something that's actually bespoke or customized to the customer's desires with a much shorter lead time. And you can do that with smarter technologies. You can actually do that locally at home. And just by doing it local, you will also reduce, of course, the whole footprint. But that doesn't work for every technology. But there's, next to 3D printing, in clothing, even in circuit boards and stuff, there are technologies out there that can do that on a competitive level. I don't think like nano, building a chip will always happen in the foundry. That's super huge.
But a phrase that emerged on this stage a few minutes ago, farm to table, you could actually say we're seeing an era of farm to table manufacturing in effect.
Yeah.
And you were also making the point on the phone that will satisfy a fundamental need of the consumer these days to know more, right? Yeah.
I mean, you see it everywhere around you. I mean, people are way more interested in not only what they're eating, but how what they're eating is made. And the same thing, like people are way more interested in clothing that they wear, the products that they use, how they are made now. And you see, it's completely different than 10, 15 years ago. So, and I think, that will continue to evolve and will change the type of demand people have. I mean, Whole Foods has just launched a new strategy about, I don't know, what is it about? That like, not so much about organic food, but like, that they're very conscious and like, what is it? That they're extremely conscious about how they do business, and that marketing is supposedly helping them increase their sales numbers again.
The consciousness could really apply across the board to almost everything we consume. I mean, let's hear, anybody in the audience have comments or questions? Okay, Jody. I know Jody's first name, but please get the mic over here. I want her to identify herself, though, of course, and I know her last name, too.
I'm Jody Westby. So I've really been worried at the deplorable state of our tech schools, tech trade schools. And so manufacturing, was the great avenue for a whole swath of our workforce that is still doing these stupid grocery cashier, auto mechanic type training things. So what can you suggest of how we could, what are your ideas for how we could upgrade tech training so that they could be more prepared for this new wave of manufacturing in the U.S.?
That's a Carl question.
Yeah, so I think it's a great question. So first of all, I think it's true. This idea of vocational training, I mean, the first thing you have to do is not make it for the dumb kids. There are plenty of people who find making things interesting that aren't the dumb kids. As it was, when we were growing up, you either went, you go to college or you're going to become an auto mechanic. By the way, auto mechanic takes a fair amount of skill to actually be good at. We got to change that. We got to modernize it for the kinds of things that people are doing. All design and all fabrication is becoming digital. So this is computer training. It's learning how to model in 3D. It's learning how to fabricate in 3D. That's another important part. It's not just the dumb kids. It's also the girls. Remember, we had to segregate them too because the girls had to learn how to cook and sew. So the first thing is, there's lots of people who are there. We have to also realize that there's a future in this and that it's an exciting future. One of the things that we just did is probably the thing I'm most proud of this year. We decided to take all of the software that we have, so every professional product, and we made it free to every student, faculty member in school around the world.
Wow.
And so, it's incredible.
Every product?
Every product.
Wow.
So all someone does is go to our website and they get a 3-year license. And to every product. And what's interesting to me about it is the number of people who are not coming from the United States who are accessing this. So the first thing that happened from our point of view is the number of people downloading the software went up by more than an order of magnitude. Second thing that happened was when you look at it, It's China, it's Brazil, it's the Middle East, it's Russia, it's India. It's exciting to see where people have this desire to do it. There's been more software downloaded in Africa than products that we've sold in our entire history.
Wow.
So there's this incredible desire, but I think along with it, what's really needed is the curriculum. And because we see a lot of teachers who get excited about this, and they have some of the tools, they have low-cost electronics, Arduinos. They now have access to even crowdfunding, if these ideas become great. They have free software from us. But the teacher, think of the teacher in North Dakota. She wakes up and says, I really want to change the industrial arts program. I want to have an engineering program in the school. And there still needs to be curriculum and materials. There's great access to info, but it's not as structured. So I think it requires a complete rethinking. But as I said to you in the first part, I think we need to rethink the academic part, as well as we need to rethink the part that is so-called vocational.
Did you have something you wanted to say?
No, I think just one thing that I would like to add, what I said earlier about the whole trying to get distribution change, because you want to build great companies here. When I look at China is building companies like Xiaomi, which is reportedly a $50 billion valuation. Now, as a 3-year-old startup, I can't convince somebody in Silicon Valley to take a risk and build a phone. We can build it, but I can't get an entrepreneur who actually has the ambition to
But there's scores doing it in China. I mean, scores of new companies doing
exactly.
it.
And that's where, if we fix distribution, then you will get it. And because the creativity and the innovation here in Silicon Valley is so much better.
Is that partly because in Silicon Valley they just don't even realize that people like you exist, and that that it's so, it can't be so fundamentally different for the Chinese. It's just they're closer to the location where the fabrication happens, so they understand it more intuitively. Is that it?
I think it's because there's too much risk for a venture capitalist to invest in a hardware startup like this here.
Okay.
Yeah, well, they're not familiar with it, and there's a lot of money that has to go into it, more than if you just are a startup that's just a couple of servers and people with brains.
Right. But it's amazing some of the things that are happening with new phones in China. Please identify yourself.
Hello, my name is Elena Alkag. I come from Vinda Ventures. I actually had a hardware startup by myself earlier, and I totally agree with your issue. It's not the design, it's not actually the technical production, it's the logistics, it's the communication, it's the cultural understanding, and other things that are the complicated part. So to my point is, do you see a future where we're not dependent on Shenzhen and Taiwan and other, it's a few small hubs where we produce a lot of these things. Can we bring back manufacturing closer to Mexico, USA, or somewhere else where we're not dependent on China for logistics reasons?
And he has a huge operation in Shenzhen. It just happened. Okay, go ahead, Liam.
It's a great question, and I think that in the hardware world, time is often the #1 currency, dollar a second. So the speed to market is #1, and in our world, that's so important. And if I move production here, which I could set up a facility here, and I could probably make a product here, the problem we'll have is the access to raw materials. The lead times for the raw materials will extend the production time. That's why the ecosystem of raw materials that's based in Shenzhen, plus the skilled workforce that's there at the moment, that's why it's one of the locations to use. And also, we operate on the basis that we're 3 hours from all the factories we work with. We're 3 days from 90% of the consumers on the planet that buy the products. And if you can send an astronaut to the International Space Center in 6 hours, you don't need distribution centers around the world to hold your products. Products should never stop moving. We ship orders of 1. Every product we make, we ship orders of 1. And we move about 10 million parts a day. So it's very possible to do it now. We also work on the basis that we're replacing inventory with data. Because again, when I go around the US and I look at warehouses, or in Europe, when I look at warehouses full of inventory that's never sold, the energy that's been wasted to put that there, to make it, to transport it, to put it there, to store it, and then to destroy it is huge. If you can cut out that, you will actually save a huge amount of energy.
Let me just add one thing. I think Shenzhen will continue to exist, but I also think there are stories that are equally good of manufacturing being reshored or happening in other places. I went to this company, they make very high precision CNC machines. It's a Japanese company. They just opened a factory in Davis, California, and they are making an entire line of machinery in Davis, and they're doing it with about 100 workers, in a totally automated plant. So it's a lights out factory. And so I think there's as many stories as that will be complementary to the stuff that's going on in China. And I think we need to reimagine, why would a Chinese company that makes the finest machine tools in the world decide to set up in, the Central Valley?
It's a really great conversation that we really should continue, but we have to wrap. So I'm so happy we got to some of those points, though. Carl, thank you so much for being here. Thank you, Marlene. Thank you, Liam.